Assalamualaikum everyone. Welcome to our course. Okay, I hope that you have enjoyed your break now. Okay, so basically we are going to learn something new today, and it is very important in terms of our current technology in Malaysia. One of them is about wind. Okay, so this is my name. The course will be, this is a 2-day course. Okay, so we will look in details on the content that we're going to learn, okay, for these 2 days, of course. So this is my name. So I'm here in UTP. Welcome to UTP, basically. You are students of UTP, so welcome to this session. So that's my email and my phone number. So should you need to know more, you can contact me later on. Okay. Okay. What about this module? This module is talking about the understanding on wind and how to apply the wind. About what? To generate electricity from the wind. Okay, so it has lots of tools to consider, okay, in terms of operation, how to control the system, how to maintain as well, and lastly to look for how it performs, whether this is the right performance that we want or not, okay, and how much power that we require in order for us to use this energy, okay, to generate electricity, whether it is feasible or not, and how much wind speed we require, things like that. All right. We will talk also about what is the growth now and some of the industrial application. Okay. And also at the end of the session, there will be a simple little question. Maybe we can discuss about that later on. Okay. So without further ado, okay, so I would like to have like all the participants here to come forward and just share about your names, why you are joining this session, and what basically the importance of the knowledge that you are seeking for your personal benefit or personal knowledge. Whatever it is you may suggest. Maybe you start with you, sir. You can come forward. Just say, okay, my name is this, and why you looking into this.
Hello, Assalamualaikum everyone. So my name is Ibnu Zakaria. So I've always been interested in robotic and programming. So one of my reason to come to this course, basically I want to know more on how wind energy can be utilized in current robotic technology. So I'm looking forward to our discussion. Yeah, I think that's all from me.
Okay, thank you. Okay, next person tak sini. Okay, maybe bang.
So, Assalamualaikum and good morning. So, my name is Ahmad Faris Nur. So, the reason why I personally would want to join this course is basically because personally I've dabbled with renewable energy like solar, for example. So, those solar panel I believe is what the future needs since as you all know, at some point our energy source like oil and for example is going to end. So I believe that at some point we need to understand more in this renewable so that we can utilize it in the future. So I think that's all.
Thank you. Okay. Next participant.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ir Dr Zaihar, and personally, currently, I live in the East Coast, specifically Terengganu. And by the beach, I feel the wind every single day. So the reason I'm interested in dabbling into this course is that I want to know whether harvesting wind energy is feasible, whether as a secondary or a main source of energy, especially in windy places like my home in Terengganu. That's all for me.
Thank you Terengganu. Okay, next.
Assalamualaikum and good morning everyone. Right, my name is Muhammad Faiz bin Bakrin, and the reason why I joined this course is because I would like to see how our country will utilize the wind energy, as we are currently using more on solar energy. Well, that's all for me.
Okay. Very,
Very simple.
Very simple explanation. Okay, next.
Hello.
Tengah sikit.
Hello. My name is Hazwani. As a power system engineering student, I would like to know on the impact of wind energy to the solar plant, to the power plant, since we know that power plant always pollute the air. Since wind energy can reduce the air pollution, so I want to try to relate between the wind energy and power plant. That's all from me.
Okay, thank you. Me?
Okay, hello everyone. My name is Umi Sufia. Previously, I interned in yacht manufacturing. That is where I am interested to know how wind can generate power, because previously in my intern, I just learned how wind contribute to the yacht movement. So I want to see another function of the wind. That's all.
Okay, thank you. And the last, today.
Hi, my name is Niknar Afiza binti Cik Isa. So I'm joining this course to know and deepen my knowledge to wind energy technology, since I want to know how wind can be harnessed to generate the power, and for the global needs in reducing the carbon footprint today, especially Petronas in 2050. So this knowledge is very valuable for me in future. So thank you.
Okay, thank you very much. Okay, thank you. Welcome to everyone. Okay, so I know now, I think it is very important course topic for you to learn. And in fact, this is not new. Petronas has been embarking on this project since, I guess, 2017, 2018. And we are still progressing in terms of developing this new technology. So let's forward. Okay, why we are looking into this course? Number one, we have several learning outcomes. Number one, we need to know the basic understanding on how the wind power operation works. So how to harness the energy, okay, and how to control it so that we can sustain the level of output that we can get. Secondly is to proceed on the installation. Installation we have two. One is onshore, one is offshore, of course. So onshore is different method. Offshore will be differently. And as Petronas are working on now, we are working on offshore application, specifically in Sarawak, in the area of Baram. Okay. And lastly, whether it is feasible or not to combine them. Okay, we are looking into how this technology can be combined, or in terms of hybrid process. Okay, so we can combine. So because renewable energy can also be combined, not only a single term. So course of content, we have a 2-day of course. Okay, we have number one is the introduction. Secondly is on the design consideration. We will talk about this morning session only about the introduction part only. In the afternoon, after we have our break, lunch break, we will continue on the design phase. Okay, and tomorrow we will talk about the installation. And also in the afternoon tomorrow, we will finalize with the hybrid. Okay, so this is basically the fundamental block of knowledge only, meaning that in every aspect we can always extend them. So this is just a brief, at least for the new engineers. You are going to be future engineers of Petronas, for example, oil and gas industry. At least you need to understand how all this works. Okay. Okay. Any question? Anything you want to talk, to suggest? Is it okay? Clear? Okay. All right. So under the first, we have first topic under the introduction of wind power. Basically, we will talk about historical type of wind, how reliable it is, effect on the environment and onshore and offshore. So all these are going to be delivered this morning only. Okay, we are going to have the first part is on several topics. We will talk about that, and the other part 2, that will be the next hour. Okay, we will continue on the rest. Okay, so if you can see, have you ever looked into, do you have any idea on the last the old TV series Little House on the Prairie? Pernah dengar? Tak pernah ya. That one was on the 80s, long time ago. When I was small, we have a TV series, and in that TV series we have this the turbine. We have windmill turbine using wind, you know. Okay, so this is just like one sample of the old wind turbine, as you can see on the diagram. So what would you think at that time wind turbine are produced for? They are not producing electricity. They are going to suck out the water for farming. So they are having that technology only for that, not for electricity. It started off in, I don't know, windmills start on the 19th century in the US. And before that, all these like Western world, all the first windmill, this will be like all those days, okay, used for mostly farming also. But most the advanced technological, okay, of the windmill mostly started in 19th century. Okay, this is more like commercialized level kind of windmill. Okay. We have horizontal, we have a vertical type of windmill. Okay. The one that we have at home, the stand fan, we call that horizontal axis. The axis is horizontal, so meaning that it will turn like that. We have vertical. The vertical like our ceiling fan, that's vertical. Okay, we have two. Okay, so as an engineer, you need to know which one is okay to use, either vertical type or horizontal type. In most design in the North Sea, like in Norway, Sweden, England, Scotland, they use what? Horizontal type, horizontal axis. They're not using the vertical because they have lots of wind speed. So if it is lots of wind, the horizontal is better. But if it is vertical, you can imagine if the blade is oriented is placing this way, you will impose some gravity at the motor. So that's why they don't use that. Okay, that's the idea. So basically, what you know now, this is the old version of the windmill. Of course, that in order for the motor to rotate, you require wind. Okay, you require some wind. So if you can consider yourself looking into helicopter, the helicopter sometimes can lift up. It can go down, they can go forward, they can reverse. What do you think what basically the system works on that? Which basically responsible for it? For the chopper to go up and to go down, to forward. What basically the mechanism that happening on that chopper? What is responsible for it? Okay, of course, propeller. They are using what, vertical, right? Okay, basically, what makes the chopper lift up, go up? What makes the chopper go down? There must be something happening to the system, right? What do you think? It's still rotating. It's still the blade still rotating, kan? But Why it can, why could, how could it go up? What can you suggest? Okay. So basically the wind, you will look into detail on this on tomorrow. Okay. But basically the idea is that if you look at the normal stand fan that you have at home, the size is not like fixed like that. It should have some angle, bending or something. That will generate the wind that you feel. If it is like flat, you will never feel anything, right? There must be some, some design, some bending, some scaling, things like that in order for you to feel the wind once the blade is rotating. Right? Similar to the chopper. When the chopper wants to raise up, to lift up, the blade cannot stay like that. It must be having some angle that the blade needs to turn, to have some angle. We call that angle of attack. Okay, so then only the idea of the movement go and up will happen to the chopper. Okay. What about going forward and reverse? The blade will just like, not like that, needs to go like this. If it is like this, then it will go forward. If it is got shifted up, then it go reverse. What about the back small propeller? It is actually for turning left and right. Okay, like if it is the blade at the back, so if it is like this, so basically it will go like that. So that's the idea. Okay, all right. So that's the way. So this helicopter is utilizing the energy by the fuel given to the chopper. But what we are learning is something that we need to turn on or rotate the blade from nature. How would the nature, like a wind, can rotate the blade of the wind turbine? How? So basically the concept still remains the same, that the blade also has to have some angle, okay, with respect to the incoming wind. If the wind is having that some speed in meter per second, for example, the role of the angle of the wind of the blade is going to adjust or play an important role to ensure it rotates. Okay, so if the angle remains the same, it will never rotate. Okay, so in order for us to apply the wind technology, we need to have the sufficient amount of wind speed to allow for the blade to rotate. Without enough wind speed, the blade will never rotate. So that is the challenge in the country like close to the equatorial area like Malaysia and Singapore, Indonesia. We don't have enough wind. Okay, less wind doesn't mean that we cannot apply. Yes, we can, but the technology needs to be changed. Okay, in the northern area like Norway, okay, Sweden, England, Scotland, for example, they have a lots of wind. So basically, the technology has been matured enough. So they just reuse the technology. Okay, they just reuse the technology then to apply the level of wind speed that they already have. If we were to buy that technology directly from them, we will never be able to apply because our wind speed is not that similar to what they are having. So make sure we need to know what basically the control aspect we need to understand in order to maneuver or to manipulate the design so that lower wind speed can also be used. Okay? So this is just a history only. All right. So the development of wind blade. Okay. So some people, you can see that if you buy the normal ceiling fan, okay, some ceiling fan has 3 blade. Kan? Some ceiling fan has 4 blade. Some ada 5 blade. And some has shorter length. And some ada longer length kan? Like Maidin punya Masjid Shah Alam tengok helikopter. Kan? So which one that you think the best to choose? Like they say that you one day you buy a house and then you want to buy the ceiling fan. There are so many types of ceiling fan out there. So which one do you think that you want to choose? Forget about the price. Just design the type that you want to choose. What do you think? What do you think? What is the relationship in number of blade in terms of wind production that you may get? Okay, increase blade, increase wind. But imagine that you are putting in your small house, small room, many blade, what happened? It's a hurricane in the room. Tornado in the room. Okay? It's not going to be good. And then you cannot do anything. Once you make up also everywhere. Cannot. Alright? What do you think? What can you conclude? What about the Maidin punya, the big one? It's very long, kan? What about its rotation? Is it fast? Very slow, right? Can you imagine if it is rotate very fast, what happen? All the table and chair will fly. Correct? So you need to also understand that the application of the rotation of your blade. Okay? What would be the best? It is not yes or wrong. It's up to you. If you want to feel that your room to become tornado, it's okay. It's up to you. You want to decide. But basically, what would be the best? Okay? So for this windmill technology, normally for horizontal type, 3 blade is the optimum. Okay? The 3 blade is the optimum. There are calculations for that. Okay? And also it depends on the length of that blade as well. Okay? So this blade is a big size of blade. Okay? It is not like 10 foot, no. The one that we developed for Petronas, 60 meter length per blade. Can you imagine 60 meter per blade? The longer size of the blade that you are putting, the more weight you are giving to the windmill. If the blade is too heavy, do you think that the wind level that you have is going to work on that or not? So there are lots of consideration you need to give in order to design something. In theory, it says yes. Okay, my calculation, 50 meter size blade is good enough with some angle, for example, and also 3 wind blade with this small number of the wind speed level. But your calculation does not include weight and gravity of the system. You need to consider that as well. Okay, so that will be in theory area. Okay, so out of 19th century until now, we have commonly power generation been developed using wind. Mostly Norway, like most of their energy generation are powered by wind. Okay, so does it mean like wind is actually cheaper than the normal hydro? They are just depending on the country's DGP. It doesn't tell that if you are using the electricity harvested by wind, you are getting cheaper price. No, it is business deal. Like say our TMB is working on this wind, it is about the same also. If they are working on solar, which is like much more cheaper, they still charges us the same level of amount of money as well. But in the terms of business perspective by the company, then they need to reconsider. If they are using coal, if they are using the normal hydropower, or they are using this, how much that they need to invest in order to get return of the investment. Okay. If you have lots of wind in your country, you need to worry about this wind technology only. Because you don't have to, once you still have the wind, we always have the energy. Okay? So this is the idea. All right? So in the beginning, they are working on maybe pumping water out for farming. Starting from maybe 19th century, then only they start to work out for generating electricity. Okay, so you know now that when you are applying wind technology, there are lots of things to consider. Number of blade, angle, the weight, and also the length of the blade. All these we will talk in surface, not maybe I will say in the afternoon time or maybe tomorrow morning, look into detail about all this. You can ask me any question if you want to know more about whatever that you think necessary, because what I'm going to deliver is just surface only. Okay? This is the one that you most probably see in the northern region. Okay? And my question, why is that, Afiza, what do you think that normally whenever they are having the onshore installation like that, all the poles are arranged in order? Why is that they cannot like one here, one there, everywhere? Why normally they are, the one row basically. It's not that far, but basically in one line. What do you think? Why they cannot just like put everywhere? There are plenty of space. My question is why they are arranged consistent in one row like this. You cannot have like one here, one there, everywhere, rojak. No. What do you think? What do you think that the designer or the engineer are deciding that we have to put the pole here, not here, and this is the way that it should be arranged? Why? What will be the reason? Mostly on the business perspective lah. What do you think?
I think they investigate on how the wind flow, so they need to line it so they can get the most wind.
Lagi? Why? Okay, that's one point. What will be why they are putting one way? Or one row like that? Huh? Okay. There are so many reasons. Okay, that could be accepted. Number one, have you ever heard about wind tunnel? Wind tunnel, like your friend here, I've been suggesting, whenever we are trying to apply this technology, we need to understand the flow or the direction, the maximum wind speed flow direction. Like over here in our block here. Our block here exactly like designed in such a way that in the certain time, this will be the path of the wind blow. Here, block 22, very, very wind speed at certain hour. So, among the reason why, because they have been studying at this area, this pass will get the most wind speed. Because wind is actually flowing in certain area. What do you think the cause of the wind flow in this world? What do you think? Okay, number one. And what about others? Yeah, have you heard about the air pocket, suddenly a plane going down because of like a certain sudden drop of plane we call air pocket? In that area there will be no oxygen, for example. Turbulent or something. What happened? This is due to air. And what caused that air to experience such phenomena? Okay. In terms of pressure. Have you ever looked into a weather channel? CNN weather channel ke whatever. You will see the word HL. Have you heard that? Have you seen that? On the weather channel map, you have high pressure, H. Sometimes they use L. those are high pressure and low pressure. This difference of the low and high pressure will create the intensity of the wind speed and also the direction of that wind. So they have been studying this. We have the MET. Kalau Malaysia, we have the meteorological, how do you spell? MET Malaysia. That's what I know. The longer one, I'm not sure. The MET Malaysia will tell you where there is a map of the wind speed. Not only Malaysia, but all over the world. And this wind speed, normally, depending on the altitude of where you are measuring that speed. Okay. Anybody have been going to Kota Kinabalu mountain ke apa ke? Tak ada Ada pergi? Okay. Anyway, the higher you go up, more wind speed you will experience. More wind speed. Some people say, okay, now Gunung Kinabalu has have plenty of wind. Why don't we put one wind turbine there? What would be your answer?
It's dangerous.
Cost. And who is going to use it? See? Some people say that, okay, if you say that the higher that the altitude is, the more wind you can get, why do you put one on the KLCC tower? Or the high what? Why there is no wind turbine ke atas tu? Why? Why? Because dangerous. All of this will be governed by some regulation, world regulation as well. Okay, let's say that you want to install something, you need to apply, like drone for example. You cannot just fly your drone anywhere. There is some regulation. The CAM will tell you that you need to get license for that. You cannot just simply fly your drone anywhere. In dalam TP ni boleh lah. Outside cannot. Because they will afraid you are going to interfere with frequency and also some, you hit the power line or things like that. So, something like that. Okay, all of these will be regulated by some agency. Okay, so over here you can look at some sample. We call that this is the area of the incoming wind. Okay, impacted on that blade. The longer the blade, meaning that the area is higher lah pi r squared. Can you see that? Okay. So over here it tells you that as you increase the length of your blade, meaning that your area of the wind impact is higher, the more power that you can get. Okay? Of course, there is a formula with regards to that which we're going to look tomorrow. But as the size is getting bigger, the cost also will increase tremendously. Okay? So, let's say that I want to design something for UTP. So, I need to know, number one, how much of energy UTP is using every month or per day, for example, like a solar. So, from there, I can say, let's say UTP are using per day, let's say 600 kilowatt of energy per day. So, I don't have to worry about the other size, I just worry about this one. Assuming that our wind speed level enough lah. If not enough, what for? Okay? So something. This is big, This is not small, it's very big. Big one. We will look detail about that. Okay, any other question? So the rest, I believe that you already had this note with you. So you can just continue later on lah. Okay? Okay, so this is some info on that. Okay. Any question with regards to some history, technological review? Okay. If you were to develop one back in your state, for example, where and what attitude you suggest in Terengganu, for example? Is there any like a place where you think the wind speed is like extra? a lot more wind speed. And this wind speed we are talking has to be consistent wind speed level. You cannot like, now we have very wind speed, like outside now there is nothing, zero wind. We need to have like consistent wind speed level. Is there anywhere, perhentian ke, redang ke, where you put, if you stay there, you will always feel the wind flowing to your body at all time. Ada tak? Mana-mana tempat? Is there anywhere in Kota Baru ke? Ada. You pergi, anybody pernah pergi perhentian ke redang ke? Ada kan? Tak ada juga. When you sit to a place, you will feel the wind all the time. I've been to a place in Malaysia where if you go to that place, you will feel the wind 24/7. I always thought that if the local government wants to venture into this, that would be the best place to be. Iaitu di Pulau Manukan, Sabah. Pernah pergi Manukan? Dia Manukan, if you go from KK, Manukan, they're not like in front, they will be at the belakang dia. You go to belakang tu, you sit one of the cliff, not cliff lah, I mean sikit kan. You stand there, you will feel the wind 24/7. I'm telling you. I just wonder why they are not trying to make a small 5 kilowatt wind turbine. It's not dangerous because once it is small, it's not what we are talking, a very big one, then it's heavy, that's going to fall down and hit people. But if it is small, you can get it turned and you can get power. If you have a chance to go to Kota Kinabalu, you just take a ferry all the way to Manukan Island. Just kan, seborang aja kan. Not to the front part of the island, but the back side of the island, there will be 24/7 wind speed. Very nice. Very nice. Okay, so that's about it. That's about all this technological review that you need to understand. Okay? Okay, so next we talk about the wind. Okay, from this you see that this is our globe. And then my question is, Hazwani, why is that the northern part is normally say the wind speed is higher? Kan? The more higher altitude, not geological level, okay, on Earth, the higher you may say the wind speed, higher speed level you get. And even if you go to Arctic or Antarctica, you can experience a very heavy turbulent wind over there. My question is, why whenever you go from equator to go up or down, either to Antarctic or Arctic, the wind speed level increases? Why? What do you think? Basic rule. The basic rule is, if it is, what about the terms, if you remember in physics, for example, what do you understand about low and high pressure? If it is high pressure, now you have high pressure, everything high pressure that you have, you need to go to low pressure, right? Okay. Meaning that if it is high, everything needs to go out, right? If it is low, everything needs to get in, right? So, if that is the case, what can you say about Malaysia and America in terms of high and low? In theory. Meaning that equator area and the northern or lower part, comparable to the equator. Which one high, which one low? Our equator ni adalah high region, high pressure region. Our northern will be low. We are talking on the surface level ni. Yeah, it's not like you getting up to the mountain ni, tak. Just same level. Equator region normally considered as a high pressure region. The more you are going all the way to the northern or ataupun southern, the lower pressure, based on the same level, the lower pressure will be. It's not like too low, but there is a number, like pressure is 1 point something, then there will be like maybe 999. I mean, getting smaller and smaller. So if you go to, like, say, Osaka, Japan, for example, you can just go through, check your pressure. Okay, that pressure at the same, let's say that you are sitting next to outside KLIA. You can measure your pressure. You can check your phone pressure, kan? Your pressure is 1.1 kPa, for example. And then once you get to Osaka airport outside, you check your pressure. That pressure should be lower than what you are getting here. Not that much, but at least smaller. If you go further out, getting smaller and smaller. It's not like 10, 20, no, a little bit less. So due to that, all of our area in the equator, high pressure, is going to move up. That's the basic idea. Okay, that is not entirely 100% true, because high and low pressure are everywhere in this globe. Okay, in theory, you will say equator is high, lower go down is actually smaller, low. So it happens also, this high and low pressure is actually happening everywhere. Okay. Let's say that you have a plane. You have a plane. Okay, you are taking plane to Osaka, for example. And suddenly, above your plane have high pressure, and lower of your plane is low pressure. What happened to your plane? Your plane will go down. And that's called turbulence. And our pilot system setting, cockpit, they have all this. They know where's the area of that difference of pressure up to the certain level, so they try not to go to that level. Because that's why whenever you take a plane and then suddenly your pilot say, or your stewardess ke apa ke, okay, please go back to your seat, we are going to experience some turbulence, for example. Because they know already that they will go through that area, that region. Plane cannot just simply go anywhere. They have to follow unless they get clearance by ATC to go and continue. Otherwise, they have to, if it is okay, then they will go through. That's why you see experience. I've been into air pocket situation several times. So it's about shock. So you need to wear your, otherwise you will fly up to the ceiling. You will injure your neck. Alright, anyway. This we call the air burst. Let's say that your plane is moving this way. What happened? Because we call that as a wind shear. Okay. Okay. So our Earth, we have 5 major wind zones. This is the name of that wind zone. So you can go through your internet, your Google, and to find out what does all this mean. This is not that important to you, but all of this will, this is the pattern of the wind area zone. And out of this will basically generate all this depending on the wind speed and also the location of that, where it is happening. In America, we call tornado. In our region, dipanggil apa? Monsoon. Maybe dekat South America, they call hurricane. That's just a name. Depending on how much the speed and also whether the speed is getting land or not. Okay? Okay. Another question, Umi. You have the hurricane. Let's say in America we have hurricane. Why is the hurricane normally we only say happening in the coastal area dia? Kenapa hurricane? Oh, sampai Chicago ada? Tak ada. Ada enggak? Hurricane tepi laut je. Why? Then when it gets to the land, the speed is less. Tornado. Pernah dengar tornado dekat Amerika tiba-tiba tengah laut? No. That depending on the area, different region. So, This is just one sample of the tornado lah kononnya. Due to the different high and wind energy, high pressure, low pressure, they can produce some burst. So if you look at the film Twister, you know Twister? Suddenly you have something, your cloud going down like that, due to that high and low pressure. So people can know where you will get the tornado in America now. They will know that when and where you're going to hit. So if they hit your home, that's it, goodbye. That's why in America, whenever you have a house, you will never have like a brick house, no. Just a normal plywood, yeah. The good plywood one. But the foundation, yes, but the rest is just because they need to protect you on that. Otherwise, when the tornado hits, a brick kena, so that's why, that's the way that it happens. Okay. This is the sample map from MAT, Malaysia, with regards to your wind speed level in our region, in Malaysia. Okay, tengok ni. So, basically, if you want to work out your wind turbine, you need to always check with this map. Okay, this is not the latest one, but basically you need to always refer to that. You need to know that where is the main source of the highest point of wind speed in your country. Okay, and also they will suggest you what's the altitude would that be. Having a consistent level of the wind speed, consistent. Okay, this number that you will have based on some level of 80-meter height. Okay, at 80-meter height, they measure a whole country. Okay, so meaning that if you are talking on double of this altitude, definitely that your speed will be higher lah. Okay, why they chose 80 meter? Because that is the most of the time the height of your pole of your wind turbine. Okay, so whenever you have a horizontal wind turbine, you have a pole. So the height of from land to that pole is normally around 80 to 100 meter height. So definitely they always measure at these heights. So there is nothing red in color here. There's nothing red in color. So basically that we don't have that much wind in the country. Maybe there is a little here. Where is it? Kota Kinabalu, Gunung Kinabalu. Betul lah kan? Meaning, we can get this one option, but it is not possible. Whatever heights that you see here are basically on top of some mountain. Okay, at that certain level. Okay, otherwise, other than that, mostly blue color, maybe a little green. All this green you can suggest. The green may be around 4 meters per second. Still, we can manage to secure some area of higher wind speed. Okay, so once you identify that wind speed, level and location, now you need to decide whether I want to make one or not. If it is onshore, normally government will not approve. If it is offshore, yes. Maybe onshore on the isolated island, yes, maybe. But not just like anywhere like KL ke mana-mana ke, put on the like coastal region, Terengganu, you make one, not possible because of the regulation on safety. Okay, so the speed, offshore wind speed is about maybe that region at the altitude of 80 meter. Okay, not that high of your wind speed. So you need to consider what are you going to do about it. Okay. Kuala Terengganu and Mersing, promising site, but sometimes you need to decide how much cost you need to spend and who's going to use it and how much power you can generate and what is so significant of that for that Kuala Terengganu and Mersing. Let's say they make one in Kuala Terengganu, for example. And what is got to do with the current installation using TMB, the normal one, or maybe Parker, Hydro. You have another one. So is it like feasible? Okay. Unless if there are competitors other than TMB in Malaysia, run the country, providing the electricity, then only we can consider. Otherwise, if the TMB, the sole distributor, sometimes I feel that we don't have to invest this. You know, we can get this to Pulau Tioman, for example, because it's very far and not easy to maintain, and also the resources also very less. We can get Pulau Tioman, Redang, Perhentian, could be one option because it's far. But in the mainland, I don't think that it's good to have this. Okay, so I guess that is basically clear enough to understand. So you just know that only. Okay? All right. So we are going to continue on this after our break. So is there anything that you want to comment on the first part of our session, that is on the historical types of wind, energy sources, availability, things like that? We have one in Pasir Mas, I think in Kelantan. I've seen one small wind turbine, somebody make one. It's not moving at all. What's the point?
Wrong place, wrong location.
Whenever you want to make one, make sure the blade rotates. If the blade not the like budak-budak punya yang coklat tu, no, it's a big one, tahu kan? Coklat picit-picit. You need to make sure it rotates. And the number of the RPM also important based on the design, okay, depending on what power transfer conversion that you require, which we're going to discuss in detail tomorrow. Okay, so on here, I can conclude that you know when this all energy started and why it is important at that time, because of course during those days you don't have that resources, so they try to make one. No electricity, normal like TMB for example, they just try to use the energy, find something, you know, in order to rotate some motor, just to use to suck out water from ground for the farming, that's all. They're still using the normal brick woods, fire to heat up, but not for electricity. Until 18th, 19th century, then they start to be much more serious in terms of energy generation for that. And then wind also, energy sources and how much that the energy is available also important for you to know what to decide to generate energy for that region. Okay? Any other comment? Okay, Hazwani, ada comment? Whatever you think on the first part? Okay, any comment? Okay, that's a good comment, but at least more comment than that. Umi? Let's say that you are engineer now. Out of this first topic, part 1, and the reason you are coming here because your boss asked you to come and to decide in your constituents whether you want to develop one, is it feasible or not? What do you think, Umi? Only from the first part, you know how much of the energy that you need to know, to have, and technology, whether it's feasible or not. What do you think that you may come back to your boss later? Sir, I think, based on my learning at this short course, I think it is okay, not okay? What do you think?
Because I actually live at Kuala Terengganu,
Mm-hmm.
and there's one point that is it Kuala Terengganu or Mersing is one of the potential place,
Mm-hmm.
but I think Kuala Terengganu is not the potential one because there's no wind there actually. It's quite hot.
Quite hot. Okay. The temperature also play an important role as well. The more hotter that you are having, basically less wind that you should experience. the much more colder air that you have, mostly the wind speed is much more getting, yeah. Yeah, any what do you comment? What's your comment? Let's say that you want to make it in Kelantan, for example. Do you think that okay or not okay?
In my comment, in Malaysia, we have to do some like critical research for this instead of use solar. So we have to study more on wind to because of like in business way we have to consider the cost.
Let's say, bang, your boss asks you, try look into something, at least we can do a little bit of the wind technology. What do you comment?
Say I noticed one line from your slide. It says the wind speed over land in Malaysia is relatively low.
Mm-hmm.
So I'm wondering if there are any studies or any technology that can amplify the output, because I think what the slide says is currently our wind is not sufficient to generate a lot of power. So what if there is technology to enhance or amplify the output? I'm wondering if there is any research.
So meaning that even though we have like a certain amount of area having a little bit higher wind speed, that doesn't promise any wind speed technology that we can make one, right? So, no other comment. Agree?
If we can find one thing that amplify the output, I think Malaysia can use the wind. For now, I think even the slide says
Yeah, there are
speed over land is
yeah, there are lots more detail on this one. Okay, that you will look into and then you will see. Okay. All right. So I guess we are almost like 1 hour already. Maybe, is it? Okay. So maybe we can just take a break. Maybe we continue on the second part just after the break. Okay. Thank you very much.